Good afternoon, and welcome to the final event of the BWSI Summer Institute Autonomous Air Vehicle Challenge. I'm Navi Charsani, the lead instructor, and I'd like to walk you through what these teams have accomplished over the past 4 weeks. Students built their own quad rotors and learned the fundamentals of flight, then moved on to computer vision, teaching their drones to track markers, detect objects, and estimate their position, before studying control and planning from PID controllers to motion planning. But some of the most important lessons happened off the syllabus. These students worked in teams and learning to Good afternoon, and welcome to the final event of the BWSI Summer Institute Autonomous Air Vehicle Challenge. I'm Navi Charsani, the lead instructor, and I'd like to walk you through what these teams have accomplished over the past 4 weeks. Students built their own quad rotors and learned the fundamentals of flight, then moved on to computer vision, teaching their drones to track markers, detect objects, and estimate their position, before studying control and planning from PID controllers to motion planning. But some of the most important lessons happened off the syllabus. These students worked in teams, and learning to divide the work, debug each other's code, and make decisions together was as much as part of the challenge as the engineering. And they did it all on real hardware, where propellers break, sensors drift, and a drone that flew perfectly in simulation crashes on its first real flight. Every team here has learned to diagnose the problem, fix it, and try again. That brings us to today. In this final event, each team will fly their drone through an obstacle course fully autonomously, no remote control, running only the software they wrote. No matter the results, the teams have worked extremely hard, so enjoy the friendly competition and please congratulate the students on all of their impressive work. Thank you.
Okay, we're gonna start.
Don't go too close to the speaker.
Got it. Stay over here, that's right. Thank you. All right, we're gonna start with team 3. So for the parents watching, the students have worked really hard on their drones. One of the main challenges with UAV racing is probably you're gonna gather as watching is you can have a great algorithm, great system that's working. You mess up once, the vehicle crashes. It's quite an ordeal to fix it. And so the students have gotten really good at doing little pit stops of fixing things, finding problems, debugging. It's been a team effort, and that's part of the focus of the course. So they're going to be running through this obstacle course autonomously. The goal is going to be to have their drone autonomously figure out where the line is, follow the line, go through the gates. It's a time trial. They get scored for every gate that they go through, and then the final time gets added on as a bonus. They're allowed to take over as a safety pilot if they think something is going wrong and recover and retry. We're going to do this round robin style. So a team's going to get 3 attempts, and then the next team's going to come up, and then we're going to keep rotating for the full 2 hours that we have for the competition. Best run is what scores for the team. Interspersed with that, we'll have teams giving presentations about their drone projects. Some of the teams have taken on extra research projects, either building modifications to their drone, building a whole new drone, algorithms that they've decided to investigate. So they've done a lot of work, and I want to showcase that, and they'll be presenting that later throughout the competition. So bring your presentation on a laptop and then plug in. There's an HDMI cord here you can plug into. Team 5, you are on deck after this team. So have propellers on, no battery plugged in, be ready.
The connecting laptop here, or
Yes, yes. I'll go over the scoring rules while they get set up. So for an autonomous gate traversal, that is 100 points per gate. For a manual gate traversal, so if they have to recover for whatever reason and want to fly through the gate manually, they still get 50 points. If you don't clear the gate, that's 0 points. The time bonus gets scaled based off the fastest team. So the fastest team will get 75 points per gate, and then that'll get scaled. They also have the option to do an autonomous takeoff and landing. That gives them extra points, or they can do a manual takeoff. Okay, cool. No, I appreciate this. Also, all right, we're getting ready to go. Team 3, you ready? And we're off. So if anyone's worked with drones, they know they're very sensitive to the vehicle configuration, the propellers, the motors, everything. So a lot of time has been spent on testing and tuning, making sure the algorithms work robustly. So we're approaching the first gate. Seems like they're doing well. Seems like they're going to clear it. Great job. Clear. Oh. All right. Technically counts as a pass through the gate. All right, guys, hurry up. Reset. Reset. They get 2 more tries. 2 more tries. Yeah, feel free to fill in with whatever you want. You want just self-filling space? Yeah.
So it appears that they attempted to clear the gate autonomously, which is an incredibly challenging task that they have devoted many days to mastering. Manually, it's a lot easier to do. I flew the course a little earlier, but all right, they appear to. But something else that appears remarkable about this drone is the intense amount of PID tuning it has gone through. As you see, it is incredibly stable in flight. There's no drifting, there's no craziness. Also, the students are probably quite good at piloting it. They're not throwing it around into things, and it is way harder than it looks. So, all credit to them for that.
Sorry, I just want to fill in as well. You were doing fine. Sorry. My bad. I didn't mean to take it away from you. I was going to make a comment about.
Okay. And the drone has taken off. And as it advances along the LED strip towards the gate, will it clear it? We hope so. And that is clear through the first gate. Turn coming up. The drone is yawing to the right. Oh. Good recovery, it seems. It's yawing again. Will it clear the second gate? Need to lower their altitude a little bit. Oh. It has cleared the second gate. And the drone advances down the LED strip, yawing rapidly to the left and to the right. Oh, and it appears to have lost the line. Nope, that's the wrong way. All right, the drone has been recovered. Attempt number 2. It approaches the third gate and clears, turning flawlessly. Look at that. Beautiful turn. All right, and oh, has it lost the line again? Nope, it's okay. It's going back and forth a little bit. Appears to be following the LED strip. Now, this last gate, there is a net in front of it, so the drone will have to increase its altitude to clear this gate properly. Oh, it increases the altitude, and oh! Good attempt, good run, good run. Good attempt, and it has collided with the gate. Now, this design is incredibly robust. It has been, I would know, dropped accidentally from extremely high altitude, and it survived. So we can hope that all the interior components of this drone are intact for the team's third attempt. Yeah.
Team is strategizing on their tactics for their third and final run, trying to make it count. Can someone from team 3 fix the marker on the last gate? It has fallen off. The last gate, the marker got knocked off. So yeah, we're in the All right, team 3, hurry up and make your last run count. Yes, it's on the computer. It should be streaming to it's on an HDMI port. I'm not sure where they're displaying it. I think it's on the webcast. If you go to the webcast, I'm pretty sure they're showing it. Dongling's laptop. And up for the final run. Okay, we're not going to count that one. We'll let you fly one more time. Whoa. Okay, I think that is your third one. All right, good job. Give him a round of applause. You gonna try again? They have 3. I think they're gonna get another round like later in the day. Oh, they're gonna get 3 more. They will get 3 more tries later after the team round robins. Take the time to go inspect your drone. Yeah.
So give a round of applause, guys. What's the team number? Give it up for Team 3. Now, this upcoming drone has a custom designed shield for the Raspberry Pi made to look like a white rabbit. I thought it was a beaver at first, but it's a rabbit. It looks really cool. So, this is actually due to the team bringing in white rabbit candies earlier, so they kept with the motif. So what you witnessed earlier was probably a result of some overcorrection on the takeoff. You do need to be extremely careful when flying these drones. They may not look like it, as the teams have done weeks of work on stabilizing them, but they are inherently very unstable. So
One other fun tidbit about this team, if you notice, Andrew will be walking around with his custom propeller hat. If you ask for a demonstration, he might give you a demonstration of it.
there's just not much I feel like I can say.
Yeah, it's hard to film that side.
Like I can just talk about the stuff I went through the course. Like
That's a good idea, though. So for the context for the course, it's a 4-week course. I'm sure you're aware. You guys have had to, bring your students from far across the country, dedicate a whole month of time having them here. Students are extremely dedicated, great students. They spent the first week learning about the basics of control for quadcopters, building up their quadcopters, getting them to fly. Then they started focusing on computer vision, using cameras to figure out where objects are in the world, things like the LED strip, the markers that are on the gates. Then they focus on more advanced control techniques to get the vehicle to control itself based off of that computer vision. And then the last week has been spent a lot of testing, debugging, figuring out issues, learning how to fix hardware problems. Teams have worked extremely hard. Team 2, you are on deck. Team 2, make sure you are set up with propellers and batteries, not plugged in, ready to go.
they've armed the drone and it is taken off. The white rabbits are airborne. White flying rabbits. And in the drone, it advances down the LED strip. We'll clear the first gate. And it is paused. It's going through. It's thinking. It's taking its time. And what's going on? Oh, and that is a clear of the first gate. Drone appears to have veered a little bit off the path of the LED strip and clears the second gate. This is fully manual. Clears the third gate. It appears to be flying in completely manual mode. But is that, well, it's going, oh, what's going on? It's doing its own thing. It's jumping up and down. And it goes towards the next gate. He's flying it backwards, which is fair to maintain orientation. And it clears the final gate extremely quickly. And lands perfectly in the landing zone. Let's give it up for the White Rabbits! Now, you might have seen that the pilot didn't really change much of the orientation of the drone. When you're flying from that cage over there, it is pretty hard to maintain orientation when you're yawing back and forth. So what I would assume is they just decided to keep it in the same orientation and fly through the gates like that. They get 2 more attempts at this, or? And the White Rabbits have returned to the starting line for their second attempt out of 3. And we see Andrew with his propeller hat. That has also been autographed by the members of the team. Oh, and Andrew is bringing out the challenge gate. This is the smallest gate they can possibly have at the course. And he appears like he would like his team to attempt it. Now, the tricky thing about this gate is the drone with propellers does not actually clear through it. So the propellers will hit the side of the gate.
Is that true? Yeah. We don't have that many propellers. So I think they should have them practice yet.
In previous attempts, propellers have been fine, but it's a little bit of a challenge, one might say. Now, something you might also notice is the custom landing gear developed for this drone. Almost all teams have added landing gear to the drone chassis, as before the drone was landing on the battery and the downward-facing camera, which, not great, but it worked. So, as you can see, the White Rabbits have all, in addition to their custom top plate, have designed custom bottom landing gear.
To the disappointment of the team, I've decided that they're going to wait to do the final gate till later in the day. This is very likely to break a propeller. We don't want to do that early on, so we're going to wait till we do that later. It'll be exciting. Keep waiting for it.
It will be very exciting. And now, they're not armed yet, but they're preparing. Let's see if the White Rabbits can do the course faster than they did the first time, or they do it autonomously. Or do something. I don't know. Either way, we're all going to have some fun. And the drone is armed and it is taken off. And it is hovering, executing a near flawless position hold. That's beautiful right there. And it is very slowly advancing down the LED strip. Extremely slowly and steadily. Unlike the rabbit in the fable, slow and steady does win the race. Will it do it? Can it autonomously go through the gate? Oh, and that is a manual recovery from autonomous mode, it appears. And the pilot has gone a little too far to the right, correcting back to the left, and clears the second gate as well. Coming around the LED strip, clearing the third gate, rounding the corner, one gate left. This is tremendous piloting by the team White Rabbits. And the drone comes around and executes another perfect, a little bit of bouncy there, executes another perfect landing in the landing zone. Give it up for team. What number is this? What? Team 5. Also known as White Rabbits.
Here's a list of random drone facts you can read off.
Oh, cool. Now, did you know that the first drone was actually invented in 1989 by Nikola Tesla? The creator of the drone believed that his invention would make the world a better place and help stop wars around the world. Well, I mean, it's done a lot in wars. Even before that, Nikola Tesla created impressive models of robots, known to the world for his incredible electric car projects. As well, this genius had proven many times that he was way ahead of his time. Tesla can deservedly be proud to have more than 270 patents in 27 countries. That's a lot of countries and patents and things. We should also be grateful to this great scientist for creating the drone. But there are many different types of drones.
Next round, next hole. Let all the teams go once. Let's all let them go once, please. Please, and then we can do it.
So, you may think that quad rotors, which are right here, are the only type of thing to refer to as a drone. But there are in fact many different types of drones. And personally, I believe the quad rotors kind of eat the lunch of the other types of drones because everybody knows them. They're famous. The other ones feel bad. Anyway, so there are also hexarotors. There are bicopters. There are fixed wings. There are helicopters, if you've seen RC helicopters. Insanely hard to pilot. Anyway, quad rotors are typically used, one, because they're pretty simple to make. You just take 4 motors, put them in a stabilized quad X configuration. You do quad X configuration 2, whatever you want. And you can get it flying pretty well. But other popular configurations do include hexacopters. Now, those are typically used by courses like the UAS SAR course, which, do they have the final event today?
No, these presentations today.
Which has presentations today if you'd like to go see that later. But the interesting thing about those is they are essentially quad rotors with 2 extra propellers. But the quad rotor has armed, and it is in the air for the third and final attempt of the morning for the White Rabbits. And the drone advances down the LED strip, I assume autonomously. It is stopping before the gate very slightly. And will it clear the gate? It has yawed once again. And we have made contact with the gate, but it has cleared the first gate. Albeit a little messily this time. We're in manual recovery mode again as the pilot takes it through the second, then the third, then rounding the corner, and stopping for a moment, coming around. He's got this. And going through the final gate. That's a little bit wide of a turn there. So we can make up for it on landing. A little bit of a bouncy landing there. But that was the third and final attempt of the morning for the White Rabbits. Or Team 5. Whatever you want to call them. I think White Rabbits a little more fun.
Team 2, please come out. Team 4, you are on deck.
No. Right. It's team 2 going up, right? Yes. Is there any And now, Team 2 prepares to take the course. As you can see, their drone is quite different from the other quadrotors that you have seen today. This is in fact a customized Holybro X500 kit with carbon fiber arms and slightly more higher powered motors. The interesting thing about this drone is that the team designed all of the CAD for the center body of the drone themselves. They also designed the landing gear themselves. This is almost entirely a custom built just for their team. Now, you may ask what the advantages of having carbon fiber arms over injection molded plastic is. Well, for one, it's much lighter. Carbon fiber, or per its strength at least. Injection molded plastic has been found to be quite bendy under circumstances like the ones which you will see today, whereas carbon fiber remains stiff and light, which is why it is popular for FPV racing drones and pretty much every other type of drone. Now, what else? Other parts of this drone that are custom are the landing gear, which they also had to design themselves. But this is truly a very well-designed piece of machinery. What's Team 2's funny name? I don't remember.
Try number 1. And the off.
Ground. Teams program these models at a breakneck pace, and the drone appears to have lost the LED strip. Now, a manual recovery. Team Gold is attempting to clear the second gate. Are they going back into autonomous mode? I believe that's manual. It appears that Team Gold has manually cleared the second gate. They're now yawing to the left as they prepare to clear the third gate. And the manual pilot brings it forward through the third gate. Rounding the corner, Team Gold's custom frame is almost ready to clear the final gate. And interestingly enough, they are yawing so that the drone is facing the final gate, which is a bit more of a piloting challenge. Oh, they're going back around. Never mind. Carefully, they guide their drone through the final gate. And now, approach the landing zone. Beautiful take. And now, Team Gold will prepare for their second attempt. Wait, that was entirely autonomous? Oh, no, just the first gate. So, as I was saying previously, each gate is marked with AR tags, which are specially designed squares of black and white that cameras can see to mark objects. The teams have been, over the past couple of weeks, programming sophisticated computer vision models to recognize the gates and make the drone traverse through them. So what you just saw in action was Team Gold's computer vision model taking their drone down the LED strip and through the gate, which may not seem like it's super complicated, but it is in fact extremely hard to do. And news from Team Gold, they are rebooting the Pixhawk. If you do not know, the Pixhawk is the flight controller primarily used for these quadcopters. So they have to reboot it probably to clear some issue or arming issue or, I don't know, a weird parameter or something. I don't know. It can be how it's going to be. Sometimes you need to power cycle it. So we're just going to wait, look at it. It's a cool looking drone, honestly. They did a good job. Another important thing that these teams have explored, which you're seeing them right now, is navigation in GPS-denied spaces. This is an incredibly relevant topic in the field of autonomous systems and also defense. More and more, we are looking for platforms that can autonomously navigate spaces without GPS, because in a lot of places where you would want drones for defense, the GPS signal's pretty bad due to all the electromagnetic interference. So naturally, it would be pretty nice if you could navigate in GPS-denied spaces. The other reason you may want to navigate in GPS-denied spaces is it's pretty hard to get GPS inside a building such as this one.
After conferring with the teams, it seems one of the challenges we're noticing is that the white line they're following is a very similar color to the white gate they're trying to traverse, which confuses their algorithms. This is a challenge I haven't had to deal with up to this point. All of the gates they've been using were not this color, so that's part of the fun.
And the X500 of Team Gold has taken off. And it appears to autonomously advance down the strip towards the gate. A steady, slow, steady sureness. It approaches the gate, increases its altitude very slightly. Will it make it through? Will it? I hope so. And if you, we have contact with the gate. And a manual recovery through the first gate. The road now yaws to the left and to the right. Is it off-board still? Now, an important thing for you guys to know is actually that the team is able to switch into off-board mode or into manual mode. Off-board mode is typically the autopilot or whatever computer or whatever program they have running. Manual mode is, well, it's manual. They're controlling it in the stabilized manner. Now it appears to be running autonomously again. And it is yawing around the turn. Beautiful turn right there. Has it lost the line? It has not yet, it appears. It's going back and forth. It's yawing a little bit. We'll get through the gate. They can do it. And Team Gold's drone approaches the gate. It looks like it's getting close to clearing it. Oh, narrowly avoiding contact with the side there. And has it done it? It appears that Team Gold has cleared the second gate autonomously. Is that autonomous? Well, the GAs are keeping track in the booth, so. Now the drone has entered autonomous mode again, and it is following the line. May seem like it's simple to code a line follower. It really is not. The drone yaws to the left and drifts to the right. And it goes. Will it autonomously make it through the third gate? It appears to have autonomously cleared the third gate. As I can see, the pilot's hands are off the sticks. So the drone has autonomously cleared the third gate, and Team Gold's drone rounds the corner in preparation to hopefully clear the fourth and final gate. But that's wrong direction. Come on. All right, it appears like it switched back to manual mode and are recovering the drone as it decided to do something else. And they round the corner. Take a moment to appreciate how beautifully stabilized this drone is. It looks like it's standing on a pillar right there. That is a very good position hold. I mean, not right now, but it was. So the drone has entered autonomous mode again and advances down the LED strip towards the fourth and final gate, which will conclude their second attempt shortly. Oh. Not one team has cleared the fourth gate autonomously yet. They will be the first if they do so. Will it do it? Oh, it appears that they have had to manually recover the drone from clearing the fourth gate autonomously. And it appears as if Team 2 Team Gold Team is going for another attempt. Switching to off-board or autonomous mode, they attempt to clear the gate once more. Yeah. They have not cleared it again, and the drone has become entangled in the net of the gate. And that ends the second attempt of Team Gold. Now, the drones have become entangled in a great many nets over these 4 weeks. You can see that there are nets above us, which should hopefully prevent them going into the ceiling if any team is a little too overzealous on the throttle. But these nets, while they get tangled up a little bit in the propellers, also do protect the drones from falling into things, which is good. You know, you don't want to drop drones from 20 feet in the air, which I did accidentally when I mixed up the kill switch with the mode switching switch. That was bad. Make sure you know what switches do what. Anyway, so okay, hold on, wait, can you look up fun facts? Yeah, trying to connect to that. Just to clarify for all the teams, there was just a discussion about the role scoring. If you take over at any point in manual to recover, that leg is manual, even if you go back into upward and try it again. You are allowed to do it in upward again if you want to test it, but you only get the manual points. Does that make sense? Hello. Yeah, give me a second. It'd be probably safer if you were behind the plexiglass when they're flying, but you don't have to be back here. Come on, like
So just don't cross like.
across the front of where the cameras are. I mean, it, you're welcome to. All right, team two is going to try their last attempt. As I mentioned earlier, the teams will be presenting about their projects later on in the day. You'll notice that some teams have different modifications to their drones. They were free to do that. This team took it upon themselves to build a whole new frame, which is very ambitious. So props to them for getting it done for this competition. Pun intended. And we're off. Try number 3 from Team Gold.
And the drone has taken off. It's in the air. And it is still in the air.
It's hovering.
Quite well, I might add. It's really hard to pull off a stable hover. They appear to be in autonomous mode. Now, these drones were quite complicated to construct. This team, on top of constructing this drone, constructed another drone. The ones that were designed for this course. They were built from DJI flame wheel parts, which are kits typically sold on Amazon, but the chassis of those drones was custom designed by Chris Lai, the race car instructor. And when we were testing that drone, it was a good chassis, works quite well. It's modular, it's quite easy to build. I mean, it's not, the arms are a little tedious to put on, but it goes together well. But okay, Team Gold is rebooting the Pi right now. So, as you might not know, this drone has both a flight controller and a companion computer. The flight controller, or the Pixhawk 6C Mini, I believe they're using, I'm not sure if they're using the A or the B version, but there's no real difference in them. Just how they work with some power modules and where some ports are. Anyway, the Raspberry Pi 5, which they are using, great little computer. It's about the size of a credit card. And this one has about as much RAM as your PC. Now, some of you who work with devices may know how expensive RAM is now. It's quite valuable. RAM, or random access memory, enables your computer to perform more tasks. And this Raspberry Pi is indeed performing quite a lot of tasks. That is where the computer vision models that detect the LED strip and the Aruco tags run. And the drone advances down the LED strip at a steady pace. It is going. And, oops, sorry. Thank you. Now, as they approach the first gate, I will discuss what they get points for. So, each run, it appears that they have taught us, oh, and that is another, oh, and we've had contact with the first gate, and that concludes the run for Team Gold. Give it up for Team Gold!
Team 4, you are up next. Come up. And Team 1, you are on deck. Get your propellers ready. No battery plugged in, but installed.
In Team 4, or these, yeah.
It's like if they win, they're champions. If they lose, they're whatever.
Okay. And now, approaching the course is Team KFC, which stands for Kachow, Friendship, and the C can stand for two different things. The C can either stand for champions, if they win, or chuds, if they do not. But either way, I believe that they are still champions. So, give it up for Team Kachow, Friendship Champions.
Just the teams are aware, we're changing the Aruco marker on the first gate. It got destroyed a little bit.
And now we're having some technical difficulties with the gates, as contact with one of the drone's propellers has rendered one of the AR tags non-functional. I mean, maybe it kind of just chipped a little bit out of it, and it's going to make it annoying for the computer vision models to detect it. So we are in the process of changing that out right now. Now, as we change out the AR tags, I thought it would be best if we went over some of the scoring. So the objective is to fly the drone through the course, and by that, around the course on the LED strip and through every single gate. You earn points for the gates that are cleared and for your lap time. Clearing the gates matters the most. So every run, of which each team gets 3, scores gate points and a time bonus. Only your best run in the slot counts. So, yeah.
Do you want to make sure that you know they're called the Flying Beavers?
Oh,
They were
that's
upset they
team.
weren't No. When they were
Flying
the first ones and they didn't get called as a team. That wasn't your fault. It was just
Sorry, forgot. I'll call them Flying Beavers next year. All right. So, the autonomous clearing of a gate follows the line the entire leg and flies through the hoop on its own, which is 100 points. A manual clearing of a gate is worth half that, which just means the pilot flew the drone through the loop. And we'll go ahead later as the drone with the number 95 takes off and bounces, is taken off. Autonomous takeoff. So the drone adorned with the number of Lightning McQueen will be taking off autonomously shortly. That doesn't count. Oh, wait, they can see us.
yeah. Put it up right there.
Oh boy. And the drone is at the starting line. Now, if any of you have seen the movie Cars, you will know that 95 is the number of Lightning McQueen, who typically will say the word ka-chow. So that's why they have that number there. It's part of the team name. Anyway, back to scoring. If the pilot misses a gate, or the drone misses a gate, they get 0 points for it. And then for the time bonus, scaled to the fastest full clear lap times the autonomous gate share, you can get up to 75 points per gate. What's a tight gate? I'm just not going to say it. Now, you can also score points for other things, such as taking off autonomously, which this team appears to be attempting. If the drone lifts off on its own without any input from the pilot, they get 50 points. And then just for a landing in the zone, which you can see marked on the ground there, the pilot gets 25 points, or the team gets 25 points. And the drone is lifting off. And number 95 is in the air. It advances down the LED strip. Pretty fast pace, I might add. Now, this has actually been significantly slowed down from before, and they appear to have autonomously cleared the first gate. And number 95 is rounding the corner. And the drone yaws to the right as it approaches the second gate. And the drone appears to have autonomously cleared the second gate. And 95 follows the line. Team ka-chow Friendship Champions drone is doing quite well as it approaches the third gate. This is one of the drones designed from the DJI Flame Wheel kits. As you can see, the students have added their own custom landing gear. And they have autonomously cleared the third gate. This run is going remarkably well for Team ka-chow Friendship Champions. And drone number 95 approaches the fourth and final gate, which, if I might add, is in my opinion the most challenging. As you can see, the altitude is corrected. It appears to be there is a manual input there as the drone yaws around. They do not appear to want to risk entering this gate autonomously. Steadily, the pilot guides the drone towards the gate, Will they clear the fourth gate? And they appear to have cleared the fourth gate. Amazingly quickly, I might add. And number 95 approaches the landing zone for a steady and perfect landing. Give it up for Team KFC. Not sure how to on until they have something. And now, the team prepares for their second run. The first one went remarkably well. They cleared the first 3 gates completely autonomously before having to recover before the fourth and final gate. Now, the important thing to know here in regards to scoring is the difference between autonomous and manual gates. So you can take manual control at any time to protect your drone. It will never disqualify you, and you're going to recover and rejoin the course. Autonomous credit is learned leg by leg. A gate scores autonomous only if the drone flew the entire leg into it on its own, following the line from the previous gate. So for example, if you flew between gate 1 and gate 2, say you lost the line, you came back and autonomously went through the second gate, then that does not count as an autonomous clear because you had to manually correct. So with reports from Team KFC that they are cranking up the speed on this one. Let's see if this drone is as fast as Lightning McQueen. They're keeping track. No, it was like 40. Oh, it seems I was able to fly. Sorry, that was perspective. You just gotta make sure you know. Oh, and the drone is taking off. Increase in throttle. Hits the ground. Increase in throttle. Oh! A devastating crash. What happened there?
Make sure the drone is disarmed and kill switched, please.
So as you may have just heard, the team must make sure that the drone is disarmed and kill switched. There are 2 safety measures on these quadcopters. The first is the arming switch. It is a switch on the absolute left side of the controller that when flicked down spins all motors at about 15% power. The drone cannot take off when it is not armed. Then, the second measure, well, typically you may disarm a drone to disable its functions. However, if you wish to, say, kill it midair, say the drone is careening rapidly towards some hapless pedestrian, you can kill it with another flick of a switch, this time the one towards the rightmost side of the transmitter.
Next team, please come up. That was the end of their run. Please, next team come up.
Yeah, they're optical flow.
Due to optical flow issues, Team KFC has decided that that will be the end of their run. Give it up for Team KFC! What's their name? And Team 1 approaches the booth. Are they the White Rabbits? Team 1? What do I call them? And now, Team Cap V approaches the course. This name is derived from the initials of every single team member. As you can see, they have also created custom landing gear for their quadcopter, and they are using the DJI Flame Wheel kit. Something important to note about this kit, it is slightly more bouncy in flight than carbon fiber drones, and the arms are a little bit more heavy for the rigidity that they provide. However, the advantage of this chassis is that every single part can be easily replaced. It is modular, almost entirely 3D printed. The only parts that are not 3D printed besides the electronics are the arms, which can be ordered with same-day shipping from Amazon and get here tomorrow. In fact, if you're checking out drones, I highly recommend to check out this kit. It's pretty cool. Now, something you may also notice is the half sphere around the Raspberry Pi at the top. This is designed so the team is able to access the GPIO pins and USB ports of the Raspberry Pi 5 so that they might configure it properly. Issues that were had in previous years is while the Raspberry Pi was well protected, it was incredibly tedious to access. So hopefully, this platform can be used in other drone racing courses in the future. Now, as you will see in the student presentations coming up shortly, the students have also submitted custom project proposals. This is essentially changes they would have liked to make to the drone or other questions they would have liked to have seen answered that do not entirely fit within the curriculum of this course. Some of them have included customizing the various hardware on the drone to create that X500 kit that you saw flying earlier. Either way, each drone is customized to each team, and there is not one that is the same as the other. What's up? I don't know how to do this. Now, what are they doing? Good? Wait, is everything okay? Okay. So, after some. All right. Doing great. Thanks. And the drone has been armed and is taking off. Is it autonomous? I believe. Manual takeoff as the drone advances down the white LED strip. Now, something you may notice is that the tiles of this floor are covered in tiny little triangles. That is not just because it looks kind of cool. It is because the optical flow sensor mounted on the bottom of the drone, which helps in those beautiful position holds that you have seen, requires features to map. An optical flow sensor takes various images and maps the features between them to determine how much the drone is moving. With this information, a drone can correct its movement. However, if there are no features, the optical flow sensor does not like it and can give very bad information to the drone, which leads to some interesting things happening. And we see the drone of and Cap V's drone is approaching the first gate, and like the others, It appears to be yawing to the left. Is it confused? And a manual recovery through the gate as they have cleared the first gate. And the drone advances autonomously down the LED strip once more. It appears to have stopped. Manually moving forward. The drone continues into another manual recovery. Speaking of the optical flow sensor, during the course we did actually have some issues with connecting it, as the cables were extremely limited in the amount that we were able to find. So the cables themselves were somewhat specialized. They connect to the CAN port in the Pixhawk, and they enable the optical flow sensor to talk directly to the flight controller. As the drone clears the second gate. I think that was manual. I believe that was manual. Yes. Then it autonomously follows the line once more and approaches the third gate. Cat B's drone is doing quite well, quite well. And as the drone yaws back and forth, slightly, throttle is increased, and it clears the third gate. Oh! We have seen a collision with the third gate, ending the first run of Team Cap V. They have 2 attempts left. And a team member hurries out onto the course to recover the fallen drone. Now, as you may see, the drones are colliding with the gates, but this is nothing compared to how much they collided with the gates during testing. Seriously, it seemed like almost every couple of minutes they were hitting the gates when they were testing. This is really a testament to how much each and every one of these teams has improved from testing to the final event. They have all put in tremendous work and tremendous hours to make sure these drones have gotten to the point at which you see them today. Throughout the course, I have seen tremendous work, tremendous progress from every single student in the course. They should all feel very proud of themselves for what they are accomplishing here today. And Team Cap V is performing maintenance on the drone. What's up? A battery swap. Each drone is powered by a 3S1P 5000 milliamp hour Gens Ace lithium polymer battery, or in short, referred to as a LiPo. Now, we'll dissect that. First, 3S1P, which means that there are 3 cells wired in series and 1 cell wired in parallel, giving a voltage of 11.1 volts. A LiPo means that it is a lithium polymer battery, or essentially that it is just created by lithium battery cells, which were the aforementioned cells I discussed earlier. And the team has changed out their battery and appears as if they are ready to fly once more. This is Team Cap V. keep moving around. This is really fun, though. It is awesome. Now, back to the lithium polymer battery. It is 5,000 milliamp hours, which is quite good for a 3-cell battery. Typical 3 cells go anywhere from 1,600 to 2,200 milliamp hours. In case you were wondering, milliamp hours is essentially a measure of how long the battery can run for. So these are actually quite nice. In addition, Gensace is a good battery manufacturer. And Team Cap V is ready to fly, as we have received the OK symbol from the... Oh, they're not yet. They're getting there. Sorry for the confusion, folks. All right. Okay. So, anyway, the importance of getting good lithium polymer batteries is mainly because the bad ones don't charge very well, or they have fewer charge cycles in them. These batteries, hopefully, will last for quite a long time and many more drone flights to come.
Just an update on the score. Team 4 is leading with 419 points. Never mind, we will fix the scores and come back. Never mind.
See. As is the problem. And now, as the teams prepare their drones, I don't know, they're still working on it. They have Team Cap V still has 2 runs remaining. Their first run, they did quite well and autonomously cleared a decent number of the gates. And the drone's propellers begin to spin as it lifts off into the air once again. It appears to be being flown manually. Executes a quite rather nice position hold. Look at how stable that is. It advances down. Yeah, oh. It has stopped. It's moving forward again. Towards the gate, advancing down the LED strip. Autonomously. You can see the drone pausing to identify the line. It sees the gate. Now, the library used for this computer vision is typically OpenCV. OpenCV is an open source library for Raspberry Pi that can be installed through Python. It enables Intel RealSense on the front of the drone to detect, just barely avoiding contact with the side of the first gate as they manually take control of the drone and clear the first gate after autonomously going down the LED strip. It appears that the drone has shifted back into off-board mode again and is now autonomously advancing down the LED strip. As the drone rounds the next corner on the track, it has lost the LEDs. It is quite far off course now and is being manually recovered. A slight overcorrection. As the pilot manually brings it forwards. They appear to have shifted into autonomous mode again as the drone goes down the LED strip. And the drone has cleared the second gate. Entering manual recovery mode, it has gone out of the side of the course once more. Taking those turns a little wide, I see. And the drone is hovering completely off of the track. Will it return? Can it be recovered? I hope so. Again, take a moment to appreciate the position hold on this drone. Look at how stable it is in the air. Look at how little it's drifting. The drone has been shifted into off-board mode again and is autonomously going down the track. It advances towards the third and second to last gate. And you can see the computer vision model keeping it on track. And the drone has autonomously cleared the third gate. The drone has been switched into manual mode to be recovered. Now, something to note, and the pilot expertly guides it through the fourth and final gate before bringing the drone of Team Cappy down for a flawless landing. And now team member from CapV heads out to retrieve the drone for the third and final attempt of the morning. Hi, thank you. Thank you very much. Just trying to have fun with this, get everybody engaged. Not yet, no. I mean, sure. I had to. Feel like I'm gonna probably wait until the teams are going towards a certain. I feel like we're gonna have an intermission in the middle. Yeah. Although if we don't, then definitely yes, please. Although could you, you know where you can find water? Yes. I've just been talking for a while now. Thank you so much. Thank you. All right, and we see that Team CapV is performing maintenance on the drone. Now, this particular member of the team has programmed some rather impressive things. Yes? Is good? Okay. All right. And oh wait, hold on. Should I talk about middle class? I already mentioned. Oh, I was. The particular team member you saw program fixing the drone has programmed some rather impressive things, including a custom model that optimizes the path the drone takes to go through things. It is very cool. I have seen it. It's pretty awesome. And we await Team CapV's takeoff for their third and final attempt of the morning. As you can see, Team CapV has been doing quite well through their past two runs. And in truth, all the teams have been doing quite well throughout their runs, despite a few unfortunate collisions. And now the team studies the ground control station as we prepare for the third and final liftoff of this turn. Now, something interesting to note about these drones is they actually do possess a depth perception camera. So on the front, you will see is mounted the Intel RealSense, which, while it does have just standard camera capabilities, it is also able to perceive depth through not only a LiDAR sensor, but also two cameras. It is a stereo camera module that perceives depth in that manner, but, oh, come on. It is a stereo camera module that perceives depth by taking the images taken from two cameras and finding depth through them, like human eyes. So, that has been incredibly helpful to the students when detecting the gates. I could talk about testing. Talk about testing the drone.
Yeah, so maybe stay away from negative things. Well, there.
And the drone has been armed. And as the propellers spin up, it lifts off. A little too high. They need to lower the altitude a little bit, and they advance down the track. And stop. And advance some more. And they're going forward. And the quad rotor autonomously advances towards the first gate. Well, it cleared autonomously. And a manual recovery, but ladies and gentlemen, the drone has cleared through the first gate. As it appears to autonomously advance down the line towards the second gate, and it has been recovered manually again. The drone slowly crawls down the track and yaws to the right as it appears to approach the second gate and has drifted off the track again. It yaws a full 180 degrees. And the pilot manually guides it back towards the track and the gate. And the drone slowly ventures down the track towards the second gate and manually clears the second gate. And narrowly avoiding a collision, the pilot guides the drone further down the track. It appears to have been switched to off-board mode. The pilot's hands are off the transmitter sticks as the drone advances further down the track. Approaching the third gate. And the drone is taking its time. Narrowly avoiding a collision with the third gate. It clears the third gate that believes to be autonomously. As it rounds the corner and has drifted off the track once more. The drone advances down the track at a rapid speed towards the fourth and final gate. Will it clear it? Oh! And that concludes the third and final run of Team Cap V after a collision with the fourth gate. fine. See you off to grab lunch, and then she said I might just grab lunch with it. Okay. I'm just gonna keep. Actually, take over from it. Yeah. All right, that was the first round of teams. We're going to do a second round. The teams are going to get another 3 chances to see if they can have improved anything. They've had chance to look at some of their code, some of the data they collected on the first flight. As I mentioned earlier, most teams struggled a bit with the first gate, with it being white and the light they're trying to follow being white. So I think they've made some tweaks to their code to try to handle that. We'll see if that works, and they are more successful in the second round. We will also have Team Syracuse has joined the competition. They will be flying a manual flight later today. So update on the score. Team 4 in the lead with 419 points. Team 3 second with 316 points. Team 2 third with 281 points. Team 1 with 280 points, and Team 5 with 225 points. Very close. Still anyone's game. The Flying Beavers are ready for their second round. Beavers are the MIT mascot, for those that are aware. So the team took inspiration for their team name. Take this opportunity to talk about some fun MIT facts. Does everyone know that in the Infinity Corridor, which is right near the dome, twice a year, an astronomical event lights up the length of the 825-foot infinite corridor that runs through the center of campus? And in January and again in November, the setting sun aligns with the third floor windows, flooding the corridor with a stream of direct sunlight that dazzles spectators observing from the west end of Building 8. Oh, and we are off. Team Flying Beavers is attempting to take off. Attempt number 1 on their second round, and they're off autonomously. Clear the first gate easily.
All right, hitting the second turn. Oh, and they are on. They were on track. Okay. Yeah. If you. All right, technical difficulties. The line was disconnected at the end, probably due to prop wash. We are going to refix and rerun. We are going to fix the line and redo that attempt to give them a fair shot. All right, we're going to have to be a little more strict on time because we're running low if we're not going to have every team go. So please hurry up and start your run. All right, and they're off. Speeding through the first leg, clears the first gate autonomously. This is where they got tripped up earlier with the broken line. Let's see if this helps. Seemed to make the turn, and oof, they've overshot quite a bit. Got into the other net and lost a prop. All right, quick reset, guys. Quick reset, please. Due to time restrictions, we're going to change to 2 attempts per run. We're not going to have time if we do 3 attempts. That was their first because the line was broken, so they get 1 more and then we will be done for this team. So team, the next team be on deck and be ready. And they are off on their final attempt of this round. They make the first gate again. Most teams have been tripped up by this. Seem to be robust. And got lost on the second turn. Where are they going? Oh, they are going to hit the wall. Great. All right. Give it up for Flying Beavers. All right, next team, you're up. This is Team Fanta from Syracuse. They've traveled all the way here. They've had a very challenging setup. They were not here in the course like the rest of the teams to be able to practice as much. So give it up for Team Fanta from Syracuse. Some more fun facts about MIT while they set up. MIT currently counts 98 Nobel laureates among its faculty, staff, and alumni. Find courses on labor economics with 2021 Nobel laureate Joshua Angster on OpenCourseWare, or enroll in MicroMasters programs in economics with Nobel laureates Esther and Banjari. MIT is really has a subculture known for pranking. Students have a long and storied tradition of elaborate practical jokes and pranks. If you go into the status center, you might see some hints of those. There's a car that's set up there where students set up a car on top of the dome as a prank. There's also a prank where there's a joke that MIT students have to drink from a fire hose constantly the way they learn and have to deal with a lot of information. So someone actually set up a real drinking fire hose that you can actually drink from inside of the status center. And we're off. Team Fanta's arming. All right, we'll give them one more reset. Second try. And Team Syracuse clears the first gate. Team Fanta. And give it up for Team Fanta. All right, next team on deck, you are up. Team 5, White Rabbits. Team 2, prepare to be on deck or be on deck. Reminder, you get 2 attempts. 2 attempts. On the scoreboard. Yeah, you want to do it first try? Yeah, you want to try? All right. White Rabbits have declared they want to try the tight gate. No one has tried this so far. It is quite challenging, very tight. We will see how good their skills are. While we wait, some more fun MIT facts. MIT has a long storied history in the development and understanding of AI, from Marvin Minsky's seminal work in neural networks to Joe Biolonwini's groundbreaking research into racial and gender biases in AI systems. MIT holds 3,781 active patents and is ranked number 2 in the world among universities holding utility patents. Up to you. Find this interesting. It's like this. It's kind of interesting.
How many smoots? Now, you may be wondering, what is a smoot? Well, there are 17 smoots. In 1958, Oliver Smoot, class of 1962, with his Lambda Chi Alpha brothers, measured the Harvard Bridge using Smoot's 5-foot 7-inch frame as a ruler. They found that the bridge was 364.4 smoots long, plus an ear. So, and the propellers begin to spin as the White Rabbits take off. Now, square fast drone. It advances down the track towards the gate. For their first attempt of the second run that they are doing. Now on the second run, each team only gets 2 attempts. And And the drone is hovering. It's still in the air. As it yaws around the track and approaches the second gate. You can see that adorable little white rabbit face as it autonomously clears the second gate. Look at it, it's adorable. Anyway, and the drone, oh, it appears to have veered off course as it is manually recovered and brought back to manually clear through the third gate. Then the pilot expertly guides it around, taking the turn a little wide, and brings the drone of the White Rabbit to the fourth gate, which it effortlessly clears. And now, the final challenge gate. Interesting thing about this gate is the propellers don't actually fit through it. Well, I guess they do! And the White Rabbits have cleared the final gate and landed flawlessly on their first run of the second run. Whatever. Second showing slot, whatever the heck it is. After a tremendous first run, let's see how their second one goes. Now, interestingly enough, the gates that you saw, the challenge gate, was not used. Typically, they had almost no opportunities to test with it, so they are flying through it manually. As you can see, it is just barely wide enough to get the drone to fit through. And it is a tremendous challenge for them to get through it. So, and the propellers begin to spin as the drone is armed and takes off for the second and final time of the day. And the White Rabbit, it advances forwards towards the first gate down the line. And it's hovering. It's going. All right. Slow and steady. A little faster than the other ones, I guess. But... And just barely, it makes it through the first gate autonomously. And the drone is hovering again. And slowly but surely making its way down the line, unlike the rabbit in Aesop. But it's hovering. It's hovering again. It's not advancing very much. Nope, some forward progress from the autonomous mode. As the White Rabbit rounds the corner. It appears to have been manually recovered. As the pilot, and a collision ends the second run and the final run of the White Rabbits. Give it up for the White Rabbits! Team Gold, you are next. Team Gold, you are next. Team 4, you are on deck. Team 4, you are on deck. And it appears that the gold team's Polybro X500 may have some difficulties fitting through the challenge gate. It has been removed from the course. Now it is important to note that each team is only granted 2 attempts for their second run. And the gold team has placed their drone at the starting line. I mean, there's no real line, but it's a general area. You know. We can imagine there's a line there. As they wrestle with Q-ground control, performing final checks, the drone is preparing to take off. Yes? Oh. Now, a little bit of background on the Holybro X500 frame. This frame is supplied by drone company Holybro, which built the X500. It is a stable carbon fiber chassis. Oh, and the drone is armed and it takes off. Takeoff appears to be manual, and the drone has yaw approximately 90 degrees to the left. The drone has been switched into upward mode, and the pilot's hands are off the sticks as computer vision takes over, and the drone advances down the track. Now a little bit of background on the Holybro X500 kits. Holybro is actually somewhat tedious to work with as they have very long shipping times. And these drones were actually procured 2 years ago during the 2024 BWSI program, which I am an alumnus of. We received these drones in the third week and were able to get them flying for the final event, and they have served with BWSI for the past 2 years. They're incredibly durable, but the motors are a little bit overpowered for the tasks which we have them do. Now, these kits do come with a stock landing gear, but most teams have opted to remove it, as it is not especially great for taking off, and as it is so far below the drone, it can create a turning moment that causes the drone to pitch onto the floor and destroy the propellers, which are not especially easy to replace. Which is why you can see the custom 3D printed landing gear created by the Gold team on their drone. And now we see that the quadcopter is approaching the first gate, but it appears to be slightly confused. It is yawing back and forth. It is rolling back and forth. Will it clear the gate? Gold team only has one attempt after this. So we hope it does. And it appears to be going through the gate. It is moving towards the gate, narrowly avoiding a collision. Oh, careful now. Almost touching the gate. Barely brushing it. Will it survive? Raising altitude. The propellers graze the gate's fabric, and the drone clears the first gate. As it advances further down the track. And it is hovering again. Take a moment to appreciate the beautiful position hold capabilities of the custom-built Holybro X500 kit that Team Gold has assembled. I know I've said this many times throughout the day, ladies and gentlemen, but a good position hold is incredibly hard to achieve quadcopter. They are nefariously unstable when not calibrated and tuned properly. Now, the teams have actually spent weeks working on PID tuning for the controllers on the flight control board. Oh, and a loss in altitude there. suddenly yawing with a rapid rate. What is the objective of these changes made by Team Gold? Anyways, the children and students have spent weeks tuning the PID parameters for their drones. Now, this enables them to properly control them at slightly better rate. But now you may be wondering what a PID controller is. As the drone clears the second gate, but a PID controller stands for three things: proportional, integral, and derivative. So, the three components: one, reacts to the present error, proportional. It multiplies the current error value by a gate. A larger error gives a larger correction. But relying only on the proportional error sometimes can leave a small permanent offset. The integral addresses accumulated past errors. As the drone approaches the third gate, will there be collision? And the drone has chewed through the AR tag and crashed after colliding with the third gate, ending the first attempt of the second run of Team Go. They have one attempt left after this. I also believe that we will probably need to change that AR tag. Now, the I component of a PID controller is the integral. So it takes the residual offset from using only the proportional response and forces it to 0, so that the system reaches the exact target value. And finally, the D component, or the derivative. This component of the controller predicts future errors by looking at the rate of change. It dampens its response, counteracts fast oscillations, and reduces overshoot. Working together, you have a PID controller, which is what is typically used in most flight controllers for drones or fixed wings, or even, as you will see in race cars. Now, this gets me back to PID tuning. The students have been, over the past 4 weeks, exhaustively tuning their PID values so that their drones are incredibly responsive and function almost perfectly. Tuning the PID values requires moving the drone back and forth on a proper axis of control, checking the logs, and adjusting the appropriate parameters. Alternatively, the software that the flight controller is able to connect to on the computer to ground control does offer an auto PID tune wizard. And Team Gold is having technical difficulties right now. Please stand by. Now, the flight controller that every team uses, which primarily utilizes a PID controller, is the Fixhawk 6C Mini. The advantage of this over the typical Fixhawk 6C is one, its size, but two, you do not have to use an external PWM out board to connect peripherals, such as, or actuators, such as, the motors. Or for the fixed wing, that would be the servos and singular mode. But how the Pixar controls each drone is it outputs PWM signals to each of the 4 ESCs, or electronic speed controllers, that are connected to the brushless outrunner motors in each one of the drone's arms. In essence, it has little plugs that go to the motors that tell them what to do. While the Pixar 6C Mini is advantageous due to its size, it is also advantageous due to the incredible array of sensors it is compatible with, and the incredible array of integrated sensors that it possesses. On its own, while not recommended, it can complete waypoint missions. Connected to a GPS, it can complete waypoint missions with higher accuracy. So Vixox 6C does quite well with that. But with this, it is mainly intended as a flight controller, which is quite nice because it can talk to the companion computer or the Raspberry Pi that is on the drones. How I typically like to explain this is the companion computer does more of the heavy lifting for the processing. So the companion computer is the thing that is identifying all of those gates, identifying the line on the floor. The flight controller is handling the PID controller. It is handling the inputs to the actual motors, the bare bones function of the drone. You can fly without the flight controller, but will not be able to execute incredibly complicated autonomous functions. Now you also may be wondering what waypoint missions are. Waypoint missions are when you take the drone, you specify a couple of waypoints, and it flies to them. So say I want to do a waypoint mission from here to the other side of the ice rink. I could tell the drone, go there and come back, and it would do that. That would be a simple waypoint mission. Typically, they are used with the GPS because it's easier to go to GPS coordinates than to just vaguely specify some random area and say, I don't know, go there. But that works. Anyway, the teams are having technical difficulties at the moment. And we await the next flight from Team Gold. So for those who were not paying attention previously, Team Gold collided with the third gate, damaging one of the AR tags and ending the first attempt on their second run of the course. They have one attempt remaining and are currently resolving technical difficulties. Now, the Pixhawk 6C Mini runs a firmware known as PX4. The version that the students are using is 1.17.0. PX4 has evolved in many important manners over the years. In fact, recently I was working with a rather old version running on the Pixhawk 1, released in 2014. As you may know, the drones in 2014 were nowhere near as sophisticated as they are now. And that definitely shows. When working with that old drone from 2014, the processor was somewhat sluggish. The flash memory was limited to 1 megabyte, which, you know, to us now might sound like almost nothing. But then it was quite a lot for a drone to have. Now, the FMU V2 chip, which is on the old Pixhawk 1, did have a glitch in the silicon that made it limited to 1 megabyte of flash memory. But which requires custom building of the firmware. With this one, however, you can flash DX4 to it right out of the box in Q ground control, and it works almost flawlessly. Other things that have been changed are how the motors are configured. Previously, there was a very limited motors tab in Q ground control. It essentially let you specify whether the motors were going clockwise or counterclockwise, and that was pretty much it. You could test them, you could identify them. That was really all you could do. But in the new version, you are actually able to specify not only the direction, but also the position of the motors. This may seem like not very much of a great change, but it enables BX4 to work on other frames as well, such as the dead cat frame, or the dead cat geometry, highly popular in FPV racing. You may be wondering why it's called dead cat geometry for a quadcopter. It is because it kind of looks like a dead cat that's lying on its back, with its legs splayed out. Now, this enables easier handling when you're flying FPV or first-person view, which is when you take a camera and you put it in the front of a quadcopter and you stream the view from the camera to goggles mounted to your face so that you can see exactly what the quadcopter is seeing. It is highly popular in racing. Another thing that is popular in racing is acro mode. These quadcopters are flying in stabilized mode, which, as you can see, means that they are almost always facing upright. The student controls the position of the quadcopter with the sticks. So when they move the stick forward, the quadcopter moves forward. When they move the stick backwards, the quadcopter moves backwards. They're controlling the position. This is stabilized mode. In acro mode, you're not controlling the position, you're controlling the rate of roll. So, say I were to move the pitch stick forwards. The quadcopter would not just move forwards, it would begin to rotate forwards. Because I am not controlling the position of the quadcopter, I am controlling the rate of change in which it moves in any given direction that I specify. In acro mode, you can execute fun maneuvers such as power loops. And the propellers begin to spin, and Gold Team's drone takes off for the final time today. The beautiful X500 kit moves forward down the track, approaching the gate at a rather rapid clip. It appears to have stopped and moves forward once again. Will it clear the first gate autonomously? It appears to be moving backwards. The wrong direction. Come on. Yeah, towards the gate. There you go. And the drone appears to be identifying the gate. It is yawing to the left and to the right as it approaches the first gate and appears. Oh, it is yawing 90 degrees and has collided with the first gate, shredding the side of the AR tag. All right, that concludes the run for Team Gold. Give it up for the Gold Team! And a team member from Team Gold arrives to collect the fallen drone. They put a tremendous amount of work into this. They should be very proud of it. They should also ensure that the propellers are removed and the battery is disconnected before they bring it back into the staging area. Accidents can and definitely do occur. In fact, I remember one of the first drones I was building accidentally destroyed my computer because I left the propellers on it. But that is a story for another day. In fact, when I was, just before I actually attended BWSI, I was building a drone. And I had the flight controller connected to my computer. It was connected by a USB cable, a tiny little USB cable, and it was a nice little drone. And I had the propellers on it, and me, being young and naive, thought, yes, I shall let it hover while it's connected to my computer, like that little thing in Spider-Man Homecoming. It'll be so awesome. I'll see if it can fly. And so I go to the Motors Wizard, and I was using Clean Flight, which is an old version of a flight configurator. It's now a web app, but it's typically used for less complicated drones than these things. And so I fire up Clean Flight. I go to that motor tab, and I set the slider to arm the motors, and they start spinning a little bit. The propellers are on them. They start spinning. And I'm like, all right, we'll increase the throttle a little bit. So I increase the throttle. Goes up. The drone goes up a little bit more. And I can start to feel it pushing on my hand. And then I increase the throttle to its maximum capacity. And the drone does take off. But it is connected to an incredibly small USB cord that is tied to my computer. And so the drone, in its takeoff, does a little bit of motion like this. And the propellers pull this drone into the keyboard of my laptop. And it's spinning, and if you could imagine, if you will, 4 high-powered drills spinning into the keyboard, into a laptop. I managed to disconnect it, and keyboards were flying everywhere. And it made a decent bit of a grinding noise and a smashing. And I remember my mother then was like, William, what are you doing down there? And I say to her, nothing, don't come down here. Don't come down here, please. She's like, I'm coming down. So it was very bad, let us just say. But she was very helpful, and she took me to Micro Center. And so I get to Micro Center, and the guy who sees my computer, a bit of accent, I remember, and Dell warranty allows for the replacement of most laptops if they are dropped or you spill something on them. As I clearly didn't spill something on it, I said I dropped it. I said I had it open and I dropped it on a curb. Keep in mind, there are keys that are cut in half. And there are pieces of the keyboard that are still in my wall to this day. So I ask him what's wrong with it, and he says that the screen is broken, the keys are broken, everything is broken. And he tells me that it will be repaired at no cost in 4 weeks. So, and that very computer is the same one I use today, and that I use to program a great many of the flight controllers on some of these drones. So take my computer as a cautionary tale. Do not connect the battery and the propellers to your drone when you are not flying it. And especially not when you're near your computer or because I was lucky, I have both my eyes and all my fingers. Pretty nice thing to have. So, be careful. So, there is that. Which is why we have such stringent safety protocols here at BWSI for these drones. Teams are not allowed to fly when someone else is in the drone testing area. Teams are also not allowed to have propellers and batteries on in the bench areas. And I would say that they have done quite a good job of it. And now we can see that Team KFC has returned. The drone with the number 95 of Lightning McQueen is at the starting point on the track. Ready to take off. I repeat, Team Kachow Friendship Champions has placed their drone at the starting area of the course. This is the final attempt of the day for Team Kachow Friendship Champions. If you remember their first attempt, they autonomously cleared 3 out of the 4 gates. Hopefully, on this second one, they will be able to clear all 4 autonomously. As the propellers spin, the drone is armed and takes off. Advancing down the track towards the first gate. At a slow but steady clip, but a little bit faster than 4, I would say. Drone number 95 approaches the first gate. And it autonomously clears the first gate. In addition, we are just informed that they performed an autonomous takeoff. Is the spirit of Lightning McQueen inhabiting this drone? And the quadcopter runs down the track towards the second gate. It appears to have autonomously cleared the second gate. Now the drone rounds the corner, racing down the track towards the third gate. Can it clear this one autonomously as well? It increases in altitude. Appears to stop slightly. And autonomously clears the third gate. Now the drone has begun to yaw in circles. Touches down. Lifts back up again. Changes rapidly in altitude. Yaws in another circle and then drops. And then rises into the air again. Drone number 95 has lost their dome. You can see it sitting on the ground there. They are flying without protection for the Raspberry Pi 5, which, if they crash on their roof, could lead to disaster. It appears as if the pilot has manually recovered the drone, but they are having some difficulty controlling it. It hits the ground again and gets back up. This drone will not quit. It wants to finish. And the drone sinks back down to the ground for a landing to conclude the first attempt of Team Kachow Friendship Champions. Now, for those unaware, the drone of Team Kachow Friendship Champions has taken the number of legendary Piston Cup racer Lightning McQueen from the movie Cars. Great movie. You should go see it. It appears that, along with their impeccable code, the spirit of this animated character has driven their drone to complete the course autonomously in an extremely rapid manner. And the drone has been taken back to the staging area to resolve some technical difficulties. For those unaware, Team KFC does stand for Kachow Friendship Champions. The unique thing about this code is that they have remained, unlike other drones, they remain unconfused by the white portion of the first gate. Most other quad rotors, when going through the first gate, have yawed 90 degrees to the left and followed the right portion of the first gate instead of the LED strip. This is because, as you can see, the first gate does go over the LED strip, And to the computer vision, it believes that that white portion of the first gate is, in fact, another part of the LED strip. This is the issue with computer vision. It can mistake things. The technology is still advancing, but hopefully it can get to a point where it can truly benefit humanity. And Team KFC has left the staging area to resolve technical problems with their drone. And as we're approaching the end of the day, we still have several more teams left to fly. But something I would just like to say is that every single one of these students has put tremendous effort into this course. They are all tremendously intelligent young people who have extremely bright futures ahead of them. I cannot wait to see where they go later in life. And due to technical difficulties, Team Kachow Friendship Champions is deferring their last run to a later time. Give it up for Team Kachow Friendship Champions! But as I was saying previously, every single student of this course is tremendously intelligent. They should all be extremely proud of themselves. They're all awesome. So, to the parents and guardians of these students, when they get home, please do congratulate them on their tremendous work that they have achieved and the tremendous people that they are. Up next, we are expecting Team 1 or Team Cappy. So, we wait their arrival in the netted tent or the staging area. And as I am thanking the students, I would also like to thank the parents and guardians of these students for supporting them throughout their engineering endeavors. I know that without my parents, this would not have been possible. So, Mom and Dad, thank you very much. And I would hope that goes out to the parents of all of these students as well. These students have completed an incredibly challenging endeavor, shown remarkable grit and tenacity in doing so, and have achieved tremendous results. They're all incredible young people with extremely promising careers ahead of them, which is fair considering the fact of how fast the drone industry is rising. Really, if you carry payloads, pretty much anything. But and Team 1 or Team Cappy is approaching the staging area. Now, to all who are in attendance here, thank you very much for showing up to watch us. Throughout this course, students have learned an incredible amount, and we see one of the teaching assistants going out with one of the students from this team to prop up one of the gates. Now, the interesting thing about these drones is you can actually build them yourselves at home. Like I said before, the parts are readily available on Amazon, and the chassis are just 3D printed. So if you want to encourage your students to continue the work that they started at BWSI, I would highly say that you do highly recommend that you do so. The chassis is completely 3D printed, and the CAD for these models, I believe, is available to the students online. So if the students wish to recreate these incredible flying machines, they can do so right in the comfort of their own homes. Alternatively, I would also highly recommend that if your student really enjoyed the program, you encourage them to come back as a teaching assistant. It was very fun, for me at least. And the drone for Team Cap V has been brought out. The other teams are resolving technical difficulties with the crowd as the drone is placed in the starting area for Team Cap V. Give it up for Team Cap V. Come on, guys, you can do better than that. Give it up for Team Cap V. There we go. As the drone is placed in the starting area, the team members begin to fit the propellers on it and fix any last-minute mechanical problems with the drone, which, if you know quadcopters, you know are they quite often occur. Pretty much with anything that flies, honestly. We build those things very robustly, but they do end up breaking a lot, particularly from the drops. You know the old saying, what goes up must come down. Now this team did something very different than the others with their design. As you can see, the landing gear for the drone of Team Cap V is much shorter than the landing gear of the drones for the various other teams, such as the White Rabbits. This allows for less weight on the outer arms of the drone and a slightly more stable chassis while in flight. The drawbacks being you cannot mount as many things on the bottom of the drone because you just don't have the clearance to do so. The other thing to be aware of is that piloting a drone is an incredibly complicated endeavor. You may think it's easy. You can just take your DJI out of the box, fly it around, and, be done with it. But in reality, it is incredibly difficult to competently pilot a quad rotor. It is a series of extremely small micro-corrections that you must make, and at all costs avoid overcorrections, which can lead to disastrous results. And with me, I have one of the students, Asel. Asel, how would you say your experience of the program was?
It's very interesting. I'm so grateful for BWSI for allowing me to meet so many amazing people. Oh wait, they're taking off.
And the propeller is going to spin as the drone takes off and rises to its altitude for competition. This is the first attempt of the second run of Team Cappy. So, what are your thoughts on this?
Well, so far it's looking stable. It's yawing. It's yawing like perfectly. So I'd say it has a really good shot of landing through the first gate. What about you? What do you think, William?
Judging from the performance of the other drones today, I would say that this has quite a good chance of making it through the first gate. It should do quite well. As we can see, the drone does approach the first gate. It is yawing to the left and yawing to the right. Is it fooled by the gate? It's about to collide. The propellers graze the AR tag, and the pilot recovers with manual control to clear the first gate. The drone is moving down the track towards the second gate. And as it drifts away from the track, they recover it with manual control. Now, we do have some of the students up here with us. So, how was your experience with the program?
Amazing. And it would be more amazing if William did the.
We are not going to address that. Anyway. So, and the drone appears to be approaching the ground again. As it rises in altitude. Oh! And a devastating collision with the second gate flips the drone onto its top. While Team Cappy was able to recover, they knocked the dome off of the drone. Hopefully they did not damage the Raspberry Pi as a team member goes out to collect the drone. We go to our students for more commentary.
Yeah, that crash was, as you said, we've had worse crashes in practice. Honestly, William, you should. You should.
We'd like to take this intermission to talk about RC planes. So my favorite RC plane is the FMS Ranger 1220. William, what's your favorite RC plane?
My favorite RC plane, that'd be a tough one. I would have to say the E-Flight UMX Turbo Timber Evolution, which I like due to the incredible amount of control surfaces and the lights and the fact that it is incredibly small and I can fly it almost everywhere. I could actually probably fly it in here, to be honest, but I'd really have to avoid hitting the walls. Fixed-wing RC drones are a wonderful way to get your child interested in engineering. And I highly recommend you encourage them to use that, as our students have just shared with you. As we can see, there is one attempt remaining for Team Cappy. And Team Kachao Friendship Champions is approaching the staging area. Now, Asel, what would you say is the most valuable thing BeaverWorks has taught you?
Honestly, teamwork. Teamwork was a really big aspect of this, like being able to divide it. Yeah. Yeah, because we were also like, Yeah, teamwork mostly because we have to be able to communicate with so many different people from different backgrounds and also from different aspects. Like for example, my thing is like hardware. I'm not that like involved in software, and I have to explain to the software people what I do and what I did and what I think, and they have to explain to me what they think. So communication is a really big aspect of this.
Yes. And now we're about to see the best team, William's favorites, compete. Who are William's favorites? We are.
Okay. So funny story behind that, actually. So Team 4, also known as Team Kachao Friendship Champions, asked me one day if they were my favorites. Now, as an impartial teaching assistant, I was unable to say anything as to that regard, as I do not pick favorites. However, they took the liberty to secondarily name themselves William's favorites, so that if someone asked who William's favorites were, in terms of the team name, I would have to point to that.
However, William kind of vetoed that, so I don't know. We know that in your heart, we are your favorites.
All of you guys are my favorites. You guys are awesome, okay? So, anyway, drone number 95 is approaching, has been placed at the starting area. Marcel, would you mind sharing with the audience some of the difficulties you faced during testing?
Honestly, having enough testing time was a really big difficulty. You see basically the field that we have right now. We basically had like less than a third in order to like test out and like go through gates. And it was a big problem, especially during the last days when we had like five drones simultaneously like trying to fly and test out their autonomous code at the same time. So yeah, that was a big problem. Also, like we had a lot of like we had a bit of hardware issues. Also, this is our first time working on like a system like that, so sometimes we had errors pop up that we actually had no clue what it meant. So that was an interesting experience to troubleshoot. As a TA, what was your most challenging part of this course?
Honestly, all the managerial aspects. I had not expected that I would be required to keep track of so many things and do many things, and I really had to make a decent effort to ensure I was on top of that all the times, that you guys get the experience that you needed. So, as we can see, the drone of Team KFC, secondarily known as Williams, is at the starting area. It is marked with the number 95.
Are they gonna take off? Are they not? We will see in a couple of minutes. For now, I think they're sorting out a bit of like their own technical issues, seeing if their code is up to par. Like this is what we did when we had our time. We checked if everything was alright. Besides, we have to do the like pre-flight checks as the TAs really, really want us to be safe, and so that you don't see that the crash happened, like you know, veered off to the side and stuff. Yeah, that was. Oh, you could see it taking off.
And so, the propellers begin to spin and the drone is in the air again! For the final attempt of Team Kachow, Friendship Champions. And no matter how this goes, they will always be remembered as the Team Kachow Friendship Champions.
Also secondarily as William's favorites.
Okay. So, anyway, drone number 95 is advancing down the track. It is autonomously clear at the first gate. Now approaching the second gate. Can it autonomously make it through the entire course? What do you think, Estelle?
I think they have a very solid chance of, given their previous runs were also very spot on. They cleared the 3 gates while the rest of the teams were only able to clear 2 maximum. They have a very good shot of landing. What about you, William?
I think they should be able to. But my only worry is when they hit the 4th gate. That one they have to change their altitude for. The other 3, they can just stay in a straight line. So hopefully their gate detection software will enable the drone to rise to the proper altitude to clear the 4th and final gate. As you can see, there is a net to prevent any low-flying drones from getting any ideas. What are some of the difficulties you think they're going to face?
Well, mainly getting through the 4th gate, because as you can see, their altitude is currently stable. But for the last gate, they're gonna have to like increase their altitude. Right, and that was implemented as a safeguard against like same altitude. Basically, if you hard code the altitude in place, you were able to pass through all 4 gates with extreme ease. So in order to make sure that no drone would be able to do that, they implemented a 4th gate. Of net on the 4th gate. As you can see, they've autonomously risen up, and they have passed the 4th gate. Woo!
And we see that Team Kachao, Friendship Champions, has autonomously cleared the 4th gate and is heading for a flawless landing on their final run. Let's give it up for Team Kachao, Friendship Champions!
This is an unprecedented moment. This is history. We are seeing history right now. Just as the first man walked on the moon, Neil Armstrong, this is the same exact history being made. Here we have Isha, a representative of Team Kachao.
Isha, how do you feel right now?
We feel great, and to celebrate this victory, we're gonna have a little fun run designed by our software team. So get hyped for that.
What does this fun run entail?
You'll see. So hopefully it won't end tragically, but we're gonna take some of the limits off. But we're gonna show you all the full capacity of our drone.
So something to note is actually in programming the based parameters for this drone, I did incorporate a few limits. One, an angle limit. I set the angle limit of the drone to 15 degrees and then to 8 because we were flying in an incredibly enclosed space. In fact, the space was, if you take a quarter of this current space, that was about how big it was. Yes, so the teams are just discovering that I was the one who did indeed set most of the frames for the limits because they were flying in an enclosed space and it was imperative that they probably try and not have to deal with certain aspects of that. Anyway, however, we are awaiting the fun run for Team Kachao Friendship Champions. Now, what do you want me to say, John? And the drone rises into the air! Adele, what do you think this fun run's going to entail?
I think they're gonna go max speed at like. I just hope that they go max speed, not on straight pointing directly towards us.
Yeah, that would be bad. These drones can reach maximum speed of about 40 miles per hour, which, compared to other things, may not sound like much, but in a closed ice arena where we announcers are the only people left unshielded, except by this little thing below us, that does not sound like such a great idea. And the drone's facing us now. Oh boy. But yes, untethered, these drones can move at a quite rapid pace. Not unlike Lightning McQueen. And the drone autonomously clears the 3rd gate. Rounds the corner. Hopefully it doesn't attack me. That would be bad.
Oh, William, who could attack you? Well, yeah, it's facing towards us now. Wait, it has veered off course right now. This is their manual taking off. Manual, I think?
This is manual controlled flight mode. It has reached the starting line again. And is settling down for a stable landing. Give it up for Team KFC! And it turns out that they're doing yet another run.
Here. Wait, I need my phone. Yeah.
Thank you. And the drone going to spin as the drone lifts off for what will probably be the final time today. Isha, what does this fun run entail?
The might be the fastest this drone will ever go and has ever gone.
Oh boy. You guys are in for a show.
Yeah, we should be ready to duck behind this cover anytime. Really quickly. Ooh.
So Isha, what did you do? Do you guys take off the speed constraints and the angle constraints? Are you guys gonna just do you're gonna try and speed run the course, or what is it? I see. You took out the angle limits. They say that they're cool like that. All right, and the battery is being swapped for another Gens Ace 5,000 milliamp hour, 3-cell 11.1 volt battery. It's actually a really nice battery when you don't have a Raspberry Pi and other stuff going on. The thing flies for a solid 30 minutes. It's great. So, I don't know.
So, William, I guess, what's your favorite snack?
My favorite snack. What do you mean, candy, or do you mean like chips? I like food. There's a lot of stuff.
What would you grab when you were like during lunchtime seminars, since the TAs were kind of sometimes free? What would you like grab?
So there's actually this really good Chinese truck down the street from the Strata Center, and it's called I think it's called like Chinese Foods Incorporated. I don't know. Either way, it is great. It is very affordable, which probably the most affordable you can find in Kendall. It is delicious. Probably some of the best Chinese food I've had ever. The lady runs it super nice. So yeah, I typically go to that food truck and I get chicken with noodles, and it was delicious. So yeah, that's what my favorite lunchtime snack would be. Or these homemade granola bars my mom makes. Those are really good.
Yeah, damn. It looks like you guys in the audience should go and check that out. I trust William. It should be very good. Also, William, I forgot to mention. Oh wait, Team Kachow's.
Team Machado has risen into the air, and the drone advances toward the gate. Oh my gosh, that's going fast. Not like crazy fast, but like fast for them. Okay. They're following the course. Are they attempting a speed run? It looks like they are. The trouble with going fast is that you also have to stop very quickly. The drones drift quite a lot since there's almost no friction between them and the air. Oh, are they landing again? They appear to be landing again. And we also see that the drone for Team Cappy is out at the starting area as well.
While they're setting up, William, you were a previous student that has come back to be a TA for the course. What was your favorite memory as a student?
So actually, with my team, I remember the second weekend, either the second or the third weekend of the course. I believe it was the third weekend. We all went to see Deadpool and Wolverine in theaters. We had a lot of fun. We got ice cream. It was great. and I really enjoy getting to spend the time with my team members. And advice to you as a BeaverWorks student would be spend as much time with your team members as you possibly can, because you will look back on this extremely fondly later. And yeah, it's great experience. People you meet here are going to be some of the nicest people you meet. So that is my favorite memory, going to see Deadpool and Wolverine. Movie, by the way. I mean, not like the best movie, but it's peaceful.
So would you call yourself a Marvel fan then?
I would most definitely call myself a Marvel fan. In fact, I actually did just go to see Spider-Man the other day. Great movie. You should go see it. Spider-Man movies are pretty much never bad. Just, yeah, love Spider-Man.
Oh, I'm going to see that one too. Do you have any what was your experience?
Well, I mean, the movie has Punisher and Hulk in it, and it's not like the stupid smart Hulk thing where he's not the real, like, it's the real Hulk. So, and then there's also Punisher. So, that. And Spider-Man, so, like, it's just a bunch of awesomeness. And I'm not going to reveal who the villain is, nor am I going to reveal who Sadie Sink plays, because that would take all the fun out of it. So, yeah, you will have fun though.
Thank you. I sure hope I do. So, as we can see, currently we have another team on the track. We have Team.
And Team Cappy has their drone in the starting area, ready for their final attempt of the day. We're getting mixed signals from Team Cappy. We got a wave from Team Cappy. And a representative of Team Cappy is now going to speak with the announcers. This is now Aiden. I understand you have programmed a custom flight control software. Can you elaborate a little bit on that, please?
Oh yeah, of course. So during the program, I investigate something called minimum snap trajectory. It's a type of algorithm that takes in the waypoints, and it takes a 7-degree polynomial usually, and it fits that polynomial to those waypoints, allowing you to create the smoothest path possible. And what it does to achieve that is that it takes the objective function and it minimizes the fourth derivative of position, which is snap, hence the name minimum snap trajectory. And then after that, after making that algorithm, I decided that I wanted to go faster in the sim. So I implemented something called Model Predictive Contouring Control, or MPCC. And basically what it does is that it tries to maximize the progress along a path, which is known as S. And then that is done using another objective function. So you have an equation representing all aspects of a drone, and then you try to maximize S.
Well, that is very fascinating. As we can see, your team's drone is in the air. What have you managed to implement this model on the drone yet?
There were attempts to, but the thing was that it was pretty complicated to do it because it required tuning a lot of constants, and because we only get so much time to work with the drone, the last week we only had 4 or 5 hours total, I think, plus like whatever we could fit in outside of school hours or class hours. So we didn't have enough time to like tune the constants, and also it turned out that the EKF on the drone wasn't particularly accurate.
Yeah, EKF or extended Klarman filter can be a little bit annoying to work with. So, as we can see, the drone appears to have autonomously cleared the first gate on the final run of today. So, I understood about 50% of what you said. You're just crazy smart. So, can you explain why it was a 7th degree polynomial, you said? Why 7?
You could actually go higher or lower. It's just 7 is like the standard typically because it's high enough definition to fit most waypoints or sets of waypoints.
Okay. All right. Going back to.
The drone looks a bit lost, but the optical flow is working. And the downward camera is also working. That corner right there, the second one, is possibly one of the hardest on the courses. So, if it passed that one, it's going to pass the next one. Most likely. As said by Aiden, the representative of Team 5. And it passed the third gate. It
It appears you may have spoke a little too soon. The drone appears to be having a little bit of trouble deciding whether or not it wants to go through the third gate, but it has! It has gone through the third gate and is rounding the corner. Now it has passed both gate 1, 2, and 3 autonomously. You guys think it'll be able to go through the last gate?
Probably manually.
Wouldn't be so sure. Oh, is that manual?
Now it is.
I believe that the pilot has switched to manual for the last run of the day, hoping to end it on a nice landing rather than a collision. And the drone has cleared the fourth and final gate manually. And this concludes the testing runs for today for the BeaverWorks 2026 Autonomous Air Racing course. Give these students a hand. All right. So we are all going to be heading back to the ice rink. Thank you all for attending the event today.